We're going to do some practice problems in preparation for today's quiz. So we start by finding the slope of the secant line to f of x equal 2x squared minus 3 from x equals 0 to x equals 2. Here's the formula for the slope of the secant line. So that would be f of b minus f of a over b minus a. And in this case, a is 0 and b is 2. So we have f of 2 minus f of 0 over 2 minus 0. Okay, f of 2, that's 2 times 2 squared. 2 times 4, that's 8. 8 minus 3 is 5. F of 0 is minus 3. So we have minus 5 subtract, we have 5 subtract minus 3 over 2. That's 8 over 2, or 4. Now we want to use the limit definition of the derivative to find f prime of 2, where f of x is 3x squared minus 1. So we want the derivative at x equal 2. All right, so in general, f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. All right, so now we want to find f prime of 2. So that's the limit as h goes to 0 of f of 2 plus h minus f of 2 over h. All right, so let's start. First we're going to find f of 2 plus h. So we'll substitute 2 plus h into f of x. So we have 3 times 2 plus h squared minus 1 minus f of 2. F of 2, substitute 2 into here. We have 3 times 4 is 12. 12 minus 1 is 11 over h. Okay, well we have to simplify this. All right, let's simplify over here. I'm just going to simplify what's in parentheses. So we'll do that on the side. So we have 3, 2 plus h squared, that's 4, plus 4h, plus h squared, minus 1. Okay, so that's multiplying by 3. We have 12 plus 12h plus 3h squared minus 1. So that's 11 plus 12h plus 3h squared. So this is what we're going to put here. All right, so let's do that. So we have 11 plus 12h plus 3h squared. So we have limit h goes to 0. And let's just look at this again. 11 plus 12h plus 3h squared. 11 plus 12h plus 3h squared minus 11 over h. So these 11s cancel. And now dividing by h, we have the limit as h goes to 0 of 12 plus 3h. And then when we send h to 0, this component, this term goes to 0, and the answer is 12. So that's equal to f prime of 2. In question 3, we want to find the point on the graph of f of x equal 2x squared minus x, where the tangent line is horizontal. So first, we have to find the derivative f prime of x. Alright, so remember the limit definition, f prime of x, limit h goes to 0, f of x plus h minus f of x over h. Alright, so let's first figure out f of x plus h. Okay, maybe we'll do that on the side. Okay, f of x plus h, that's equal to, here, using this function, 2x plus h squared minus x plus h. Okay, so that's 2x squared plus 2hx plus h squared minus x plus h. Let's open parentheses now. So we have 2x squared plus 4hx plus 2h squared minus x minus h. So that's 2x squared. Let's see, we don't have any, actually we don't have any like terms here, so let's just leave that as is. So this is what we're going to substitute in over here. So let's do that. Okay, so I just copied that over here. This is what we had. This is what we had here, and I just copied it over. Now subtract f of x. Here's f of x. So we're going to subtract 2x squared minus x. All right, now open up parentheses and we'll have some canceling. So we have 2x squared plus 4hx plus 2h squared minus x minus h minus, now open parentheses, minus 2x squared. Now we have minus minus, that's plus x. Now remember what I told you, when we are using, when we're taking the derivative using this definition, and f of x is a polynomial, all the terms which don't contain x should cancel. So here we have the 2x squared canceling with minus 2x squared. And here we have a minus x canceling with the x. Now everything else has h in it. Okay, so now we'll divide by h, and we have the limit h goes to 0, 4x plus 2h minus h, sorry, minus 1. Because we're dividing h by h, so that's minus 1. Now take the limit as h goes to 0, and just this middle term goes to 0, and we have 4x minus 1. So this is the derivative. This is equal to f prime of x. And it gives us slopes of tangent lines. So now we want to know, when is the tangent line horizontal? A horizontal line has slope 0. So the tangent line is horizontal when it has slope 0. So to figure out what this occurs, just set the derivative equal to 0 and solve. It's a simple equation. We have 4x is equal to 1, or when x is equal to 1/4. So when x is equal to 1/4, the tangent line is horizontal. Tangent line horizontal at x equal 1/4. So that answers our question. In number 4, we want to use the alternate definition of the derivative. So this is it right here. the alternate definition, to find f prime of 5 where f of x is equal to the square root of x minus 1. All right, so let's write down this limit. We'll replace c with 5. So we want to find f prime of 5. So that's the limit as x goes to 5 of f of x, this is f of x, minus f of c, that's this function with x replaced with 5. That's the square root of 5 minus 1, or the square root of 4, or 2. So this is 2. Okay, so this came from the square root of 5 minus 1. Remember, c is 5. Over x minus c, that's x minus 5. Okay, so we're going to find this limit, and in order to do that we have to do some manipulating. We want to somehow cancel an x minus 5 from the denominator and numerator, but we don't see the x minus 5 here, because if we substitute in x equal 5 we get a 0 in the denominator and a 0 in the numerator. We get square root of 4 minus 2, which is 0. 2 minus 2 is 0. All right, so what we often do in the case where we have a square root plus or a number or a square root minus a number, we're going to multiply top and bottom by the conjugate of this numerator. All right, so let's do that. So let's write the limit as x goes to 5. Square root x minus 1 minus 2 over x minus 5. And let me just erase this a little bit. We're going to, multiply top and bottom by the conjugate of the numerator. Plus 2 square root x minus 1 plus 2. Okay, so that's equal to limit x goes to 5. And here we have root x minus 1 times root x minus 1 is x minus 1. Middle term drops out, and here we have minus 4. And in the denominator, we have x minus 5 times square root x minus 1 plus 2. Now this is x minus 5. So there's the x minus 5 we were looking for that we want to cancel with this x minus 5. So we can do that. These two cancel. So this is the limit as x goes to 5. Okay, now we're canceling this with this of 1 over the square root of x minus 1 plus 2. Now we can actually take the limit because we no longer have the 0 over 0 situation when we substitute in 5. All right, so just go ahead and substitute in 5 and drop this limit over here. So we have 1 divided by the square root of 5 minus 1. That's the square root of 4, which is 2. Or here we have 2 plus 2, which is equal to 1/4. Okay, so that's f prime of 5. Okay, in number 5, we want to use what we call the alternate definition of the derivative to show that f prime of 0 does not exist for f of x equal x to the 1/3. So first, let's look at the alternate definition of the derivative. Okay, and here it is. We have f prime of c is equal to the limit as x goes to c, f of x minus f of c over x minus c. All right, so in this case, we want to show that f prime of 0 does not exist. All right, so f prime of 0, that's the limit as x goes to 0 of f of x, that's x to the 1/3, minus f of c, that's f of 0, 0 to the 1/3, that's 0, over x minus 0. All right, so that's the limit as x goes to 0 of x to the 1/3 over x. And just simplify that. Limit as x goes to 0, x to the 1/3 over x. So let's write that as that's x to the minus 2/3, or 1 over x to the 2/3. Well, when x goes to 0, this denominator goes to 0. Okay, that's going to 0. The denominator goes to 0. So we're in a 1 over 0 situation, and this limit does not exist. So we can conclude that f prime of 0 does not exist. Now here I have a picture of approximately what y equal x to the 1/3 looks like. It's increasing on the right, and it's symmetric with respect to 0. It's positive on the right, negative on the left. And look what's happening at 0. At 0, we have a vertical tangent line. Okay, slope infinity. Okay, so the slope of this line is infinite. And that's why the derivative does not exist, because here we have an infinite slope. So this is one type of situation where a derivative doesn't exist if the tangent line is vertical. Okay, number 6, we want to use the definition of the derivative to obtain the derivative of f of x is equal to the square root of x. All right, so let's write down the definition of the derivative. All right, this is not the alternate definition, the standard definition. Limit h goes to 0, f of x plus h minus f of x over h. Okay, so we have limit h goes to 0. Substituting in x plus h into f of x is equal to the square root of x. That's the square root of x plus h. Minus f of x, that's the square root of x, over h. All right, and we want to cancel an h from numerator and denominator, because we always have a 0 over 0 situation when we substitute in h equals 0. Okay, so to get an h out of this, we're going to manipulate by multiplying by the conjugate of the numerator, top and bottom. Okay, so let's do that. So here we have x plus h. Middle term drops out, minus x over h. And you see there's the, over h times the square root of x plus h plus the square root of x. Okay, but you see in the numerator we do have h. X plus h minus x. So this is h, which cancels with this h down here. All right, so now we're ready to, well, let me just rewrite this. Limit h goes to 0. And we did the canceling, so on top we have just 1 over the square root of x plus h plus the square root of x. Now take the limit, substitute in h equals 0, and we have 1 over square root of x plus square root of x, or 1 over 2 times square root of x. So that's the derivative. Okay, number 7 is related to question 6. We want to find the equation of the tangent line to f of x is equal to the square root of x at x equal 9. And in number 6, we found that f prime of x, or the derivative of f of x, is equal to 1 over 2 times the square root of x. All right, so to get the equation of the tangent line, we need two things. We need a slope, and we need a point on the tangent line. For the slope, we use the derivative. Now remember, we want the tangent line at x equal 9. So the slope of the tangent line at x equal 9 is equal to the derivative at x equal 9, or 1 over 2 times the square root of 9. That's 1 over 2 times 3, that's 1/6. So this is our slope. All right, so in the formula y equal mx plus b, we'll put m equal to 1/6. So we have a slope, now we need a point. Well, we have the x value of our point, x equal 9. So for our point, we have x equal 9, and y is equal to the corresponding y value, f of 9, not f prime of 9, f of 9. F of 9, so that would be the square root of 9, which is 3. 9, 3. All right, so to figure out b, what we want to do is substitute in our point. Substitute in 9, 3, 9 for x, 3 for y. So let's do that. So we have 3 is equal to 1/6 times 9 plus b. Or 3 is equal to, divide by 3 over here. 3 is equal to 3/2 plus b. Subtract 3/2 from both sides and we get b is equal to 3/2. So now we have the equation of our tangent line, and our tangent line is y is equal to 1/6 x plus 3/2.